Since you are also, they made you the organizer, it's better you can record your own session. Otherwise, you have to again, take it from them.
Say that again, sorry.
I think if you are an organizer, so you can also record your session. Are you getting the start recording button on your screen?
I am.
On your GoToMeeting desktop?
I am.
So just simply start that.
Oh, okay, started. Okay. All right.
Right. Okay. So CCNA is basically about routing and switching. This is the basic course we are doing. In the Cisco proprietary, this is the starting course or the basic fundamental course. Basically, people go for R&S. It is compulsory. Whether you are going for next levels, like you are going for other modules, even if you are going for security, you are going for CCNA ISP, you are going for CCNA wireless, this, that, any other module you want to pursue. Before that, you need to have the basic understanding of routing and switching.
Yeah.
Right. So what does Cisco do? Cisco is generally a network devices manufacturing company. It gives you routers and switches. It gives you many network devices. It gives you firewalls. It gives you routers. It gives you switches. It gives you LAN cards, so many ports, etc., etc. All these things are manufactured by Cisco. Now this company started long back in 1984 and it got its name from San Francisco. You get routers and switches of many other companies also, like we have Juniper, we have Alcatel, we have Qualcomm, 3Com, Linksys, so many other companies are also present in the market, but Cisco has the major market share. So you can call it the leader in the network devices protection. Actually, these people maintain a network academy, a school kind of thing, wherein you can enroll and you can learn your own courses. See, we have the entry level, we have the associate level, then we have the professional level, expert level, and the architect level. So these are the various levels which you can go through. The same CCNA exam, you can also take in two parts as an ICND 1 and ICND 2. Right? And if you are prepared well, you can take CCNA single paper, or you can break the syllabus into two parts and you can take it as ICND 1 and ICND 2.
Okay.
Yeah. So coming to the certification path, yeah, please ask.
No. So this is the Cisco CCNA, and then there is a CCNP. For the training. That's what I'm saying.
Yes.
Okay. All right. Okay. That's fine.
Right. Okay. CCNA is Cisco Certified Network Associate. Then you have Network Professional. Then you have CCIE Inter-Network Expert. After this, you also have CCA, Cisco Certified Architect. Right? So once you take your CCNA certification, let's say today you are taking your CCNA certification exam, you get your certificate, you pass and you get your certification, and this certification is valid for 3 years. Within 3 years, you need to get some industry experience and you need to prepare yourself for CCNP. Within 3 years, if you are not taking NP certification, your CCNA will be null and void.
Okay.
Right. So how do you understand a network, Mr. Irshad? Is that your name?
Yes, yes.
Yeah.
Can you hear me?
Okay.
Okay.
Yeah,
okay.
I can hear you.
Okay. So basically networking is you create a network by putting peripheral devices that are talking to each other on a network. That's my understanding.
Yes, you are perfectly right. Right. So network, I'll put it in a very simple term. Network is nothing but it is interconnection of devices. Whenever you try to simply connect two computers together, you try to join two systems together, there becomes your network. Right? So it's a group of 2 or more computers connected together. Grouping of computers is called as a network. See here. Here you can see the example of a small network.
Okay, so that's kind of a LAN network?
Yeah, exactly. It's a LAN. So here you see a switch connected with a few number of machines on it, right?
Okay. Okay.
Now, what is the purpose of network? Why are you trying to join the systems? Why can't we work with individual systems?
I think it's in terms of making a separate connection. So this is a more feasible way to make a connection.
Okay, yeah, that's true. That's true. That's true. That's the first point. Yes, you can share. You can reduce the infrastructure cost. We have many advantages when you create a network and when you try to work on a network. So that's the reason we are going for the networks. So you can share any type of resource on the network. You can share printers, folders, servers, etc., etc. All these things can be shared on the network. Then what are the advantages? So you have many advantages, like you can centralize the network, you can reduce the infrastructure cost, you can provide security, you can save your time. Like this, we have many advantages, because of which more and more companies are coming up with the networking concepts. Right?
Okay. Yes.
And coming to the requirements of a network. Let's say I want to put up a LAN, I want to start a small LAN. What are the requirements you need to have here? How do you guess? See, you can find a picture before you. Just tell me what are the things you need to have in order to start a small LAN, let's say local area network.
You need as far as a router.
LAN. If you are setting up a LAN, I don't.
But I mean, it's more of a cross connect switch.
It's okay. And
I mean, that's basically what you need. That's all you need.
Right. Okay. So basically, you need to have computers with network operating system. So nowadays, all the operating systems give network support, so we don't have to bother about it. Then you need to have the core component of networking, that is your NIC card. In every machine, you'll have one component, one peripheral called as NIC network interface card or LAN card or Ethernet card. So basically, if you try to assemble a machine, NIC is not a it's not a part, actually it's a peripheral, extra attachment. Right? So when you want to do networking with your machine, you will try to install it. If you don't want to do networking with your system, you can dump it. Then you have cables, you have some media. We are using guided media in the form of cables, and at the end of those cables you have RJ45 connectors. Right? And then we need to have a centralized device, which is your hub or switch. You can use a centralized device if you are having more number of machines, you want to connect 10 systems, 20 systems, 50 systems, like that. You can go for a switch or a hub. Hubs are obsolete now, so generally we work with switches. And then we need to have the IP address. So do you have any understanding about IP address? Did you ever use an IP address?
Yeah, I have assigned IP v4 and v6. I think v6 is not what we are using now, right? We are trying to get into, okay. I have some idea.
Nobody's using. Right. Okay, fine. So these are the basic things required in order to set up a LAN, the basic thing. And then...
So IP address for each computer.
Yes, of course. IP address for each computer. That's a unique address we are trying to give in order to identify a particular node.
Device. Okay. Yeah,
device or node or anything. It can be a server, it can be a client, it can be a scanner, printer, anything, any network device. Then, so how many classifications do you have in networks?
I'm not sure.
Okay, so basically you can classify them into LANs and WANs. A LAN is a local area network and a WAN is a wide area network. How do you define a LAN?
Basically anything connected, wide area access network, is that there's a distance requirement? I mean, if you're shared with a proxy server or something?
Yeah. May or may not be. Proxy is not compulsory, but distance is a mandatory criteria.
Okay. So what is it? Can you explain for me, please?
Yes.
Okay.
See here, LAN is local area network. It's a small network. Whenever you are trying to create a network and you are trying to manage a network in a limited geographical area, in a small network, in a small place, it's called a LAN. See here, network devices are connected in a limited geographical area. You can take the example of a room, you can take the example of a building, you can take the example of a campus, etc. So generally, if you refer books, it will be up to 2 kilometers of radius, but practically speaking, your Cat5, Cat6 family cables, they work only up to 100 meters.
Okay.
And usually we don't need to have any service provider's existence. We don't need any help of ISP. You can create your own LAN with your own cables, etc. And here we are going to use the switch as the connecting device. We don't use routers. We don't need to go for routers. Switches are enough for a LAN. Right. Coming to WAN, wide area network. And here we are trying to connect the network devices which are in distant places or far off places. They can be in different cities. They can be in different countries. They can be in different you can take the example of internet. Internet forms the best example for a WAN connection, and here your service provider comes into existence. We are taking the help of the service provider, right? So networks are connected with the help of routers.
Okay.
Usually whenever distance and different networks come into picture, there we are going to use a device called as routers. Let's see a LAN. LAN forms like this and WAN forms like this. So usually in a WAN you are trying to connect two LANs which are in distant locations. Like see you are maintaining one LAN in Hyderabad, you maintain one other LAN in Delhi, and you are trying to connect both of them with the help of the service provider.
Okay, these are, what are they called? Edge routers, or what are these? What routers?
Which routers?
What kind of routers are these? Just enterprise?
They can be distribution layer routers.
Okay, so this is, you have given an example of Hyderabad and the Delhi. These are in a specific corporation or enterprise?
They can be anything. I mean, yeah, they can be at the enterprise level also. They can be at the enterprise level as well.
So this is service providers. This is at the service providers level? I mean, who owns these routers?
You will own your own routers. The company people own their routers.
No,
For the WAN link, we depend on the service provider. For the WAN links, we depend on the service providers.
Okay. So
Your service provider can be anybody.
Right. You said service provider, and you are, so what are you showing? I'm trying to understand. Are you saying that these are routers are owned by service provider? Is that what you're saying, or no?
No. Again in the cloud which you are saying, you will find few more routers.
Oh, I see.
So these routers are your own company routers, your network. See, you are seeing the diagram like this. Within the circle is your network.
Okay, I see. Right.
Okay, you can take any company example which is having branches in different locations. Let's say Tata, Birla, TCS. These people have branches in different locations, so they maintain their own routers. And for the WAN links, they depend on the ISP. They can take the internet from anybody.
Okay.
And in that public cloud, you will find so many other routers.
Okay.
Right? Followed?
Right. I understand. Okay.
Right. Now, how do you understand a topology?
Network topologies?
Yeah.
Not sure.
Okay, network topology refers to the diagram of your network, refers to the layout of the computers in your network, the layout of devices in your network. Simply speaking, it is nothing but the shape of your network. Okay, see here, it's the layout of network. It defines the physical structure of network. As such, we have some topologies, like we have the bus topology, then we have the ring topology, we have mesh topology, we have star topology, then we have extended star topology. So many things are there. Let's see the diagram. So this is your bus topology, also known as linear topology, right? Your data can travel both. You can send and receive the data from first system to last system and last system to first system. Ishad, is everything all right?
Yeah, hold on 1 second. I'm just trying to set up something. Okay, yes. Okay.
Yeah.
Sorry. Okay, so this is the first topology, bus topology.
Yeah.
Okay, and
you can also call it as linear topology.
Okay, linear topology. Okay.
Right?
Yes.
Are you comfortable, Ishad? Do you need some time to settle down?
No, I'm fine. I'm just trying to set up the mic, the volume. Okay.
All right. Oh, that's the reason you're asking me. I can hear you quite clear.
You can, okay, hold on for 1 second. Let me do this. Tell me if you, okay. Can you hear me now? No?
Yeah, I do.
Okay. Hold on for 1 second.
Yeah, sure.
Okay, all right. Can you hear me now? Hello?
Yes.
Okay.
My side, it's always the same thing. I'm not, your voice is not going down.
Okay, I'm fine. Okay, all right, please go ahead.
Yeah. So this is bus topology, also known as linear topology. So this is an old type of topology which people were using in the earlier stages of networking. So you can see that we are not using any centralized device. We are not using any hub or switch kind of things here. We are simply trying to connect peer-to-peer or system to system. We are depending on the machine. So if something happens to the machine in between, it is going to hamper the complete network. If something happens to any system in between, it is going to hamper the complete network, and further communication will be affected. Let's say machine number 3 is down. So you can no doubt communicate easily from machine number 1 to 2, and further communication will be disturbed, right?
So when you say machine, so when you say the machine is down, that means the network interface card is down, or is it just...
It could be anything. It could be
Okay.
operating system issue. It could be an NIC card issue, or the
Okay.
system might be shut down. It could be
Okay.
anything.
And these are RJ45 cables that you're talking about? The one
Yes,
that
yes,
okay.
yes,
Okay.
exactly.
Can you hear me or am I very loud?
No, no, it's okay. It's very clear actually. Not loud.
Not loud. Okay.
You need time, I can wait.
No, that's fine.
All right. Okay. See here, this is your ring topology, also known as token ring topology. So in this you can send your data. The data will travel both clockwise and anti-clockwise, right? So this is also known as token ring topology. Why? Because before the actual data is sent, the machine is going to receive a token. Token is an indication for the system to be prepared to accept the data, to receive the data. Okay?
Okay.
So like this, you can also connect the routers here. We are always trying to relate a router to a PC, compare a router with a PC here in these diagrams. Then
Okay.
comes our mesh topology. So usually your mesh topology is very clumsy because it carries too much of NIC cards, it's carrying too much of cabling with it, etc.
Okay, so what's the definition of I mean, there are two figures that you have drawn here. The first one is basically showing the computer terminals, computers, and the other one is the
first,
routers.
yes. I want to show you that you have a topology in LAN, you have a topology also existing in WAN.
Okay.
WAN, basically router is a WAN device.
Okay, so the one is you're showing in LAN, the other one is in WAN.
Yes, exactly. So since router is a WAN device, we say you also have a network, you also have a mesh topology. I'm giving you an idea to imagine beyond LAN.
Okay.
Right?
Yeah.
Right. So then comes, these are all tested and tried ones. We don't use any of them right now. The most popular topology is the star topology, the most efficient with limited number of cables and maximum efficiency. So here we are going to use a centralized device. Mainly we use a switch as a centralized device and we try to connect the systems here. Right?
Okay. Yes.
See here like this. And then comes our extended star or tree topology. In this you are trying to connect 2 or 3 star topologies together. Right?
Okay.
Right. And next, let's talk about a switch. What do you know about a switch? Where can we use a switch? What is the functionality of a switch?
I mean, basically it's to transfer the calls and route it from one person to another person.
Yeah, do you do some switching in telecom? Do you use switches in the telecom?
Yes.
Okay. What devices you use basically in telecom sector?
I mean, we had uses, we had done, like 5 ESS switches and those kind of switches, Nortel, DMS switches, those kind of things, devices.
Are you still working or you're not working right now?
No.
You're not working. You're trying to change your field?
No, I'm trying to get into the networking.
All right. Telecom is fine, no?
I'm sorry?
Is telecom not working right?
No, I mean, telecom is it's a booming field. It's just, I'm trying to diversify my experience.
All right. Then you must try, one suggestion from my side, you must try voice in CCNA.
Voice CCNA?
Yes, CCNA voice. That would be better option for a telecom, for somebody who is having so much of industry experience in the telecom.
But I do not have that much of experience in telecom. I just basically support, my background has been not directly with switching, routing. It's more of working with equipment that powers, I'm working on the power side of equipment. So what is powering the...
Are you, like electrical type of thing?
Yes.
Or instrumentation kind of thing?
Yes. So more electrical. So that's why I chose the routing. And is it, you don't feel comfortable with that, or?
No, it will definitely help you. Let me tell you one more point. CCNA is actually a combination of electronics and networking. So if somebody comes from an electronics background, it will be definitely easy for him to learn.
Okay.
Rather than a non-electronic background guy, then he will have to start from the starting. He will have to take down some basics of electronics and then he has to move on to the networking side.
Okay.
Right. So let's discuss about the switch. Basically, switch is dealt as a LAN device. It's used to communicate between computers which belong to the same network. Whenever you want to communicate between computers on the same device, there we are going to use a switch. Basically, it's a LAN device. It's used for switching. So you can see a switch like this. There are so many ports available. Switches ports are available in the multiples of 8. Like you have got 8 port switch, 16 port switch, 24 port switch, 32 port switch, and so on. And this is the icon we use to represent a switch.
And that's basically to connect all the
computers in a LAN.
Computers, printers, whatever you were saying.
Yes, exactly.
Okay. It can be printers also?
Yes, you can also connect printers.
Okay.
You can, anything you want to share, you can just put that into the switch.
Okay.
Now coming to the router. Router is a WAN device. It works at layer 3. Switch works at layer 2. It works at data link layer, and your router works at layer 3, that is network layer. It is used to communicate between different networks. See here, this is how your router looks like. This is the icon we use to represent a router. Router is a WAN device. It establishes communication between different networks. Now, do you understand the difference between same network and different network?
Between different networks. Yeah, I mean, different networks would be something that you are connected through ISPs or...
Yeah, right. Can you, since you said you already have worked with IP address version 4, can you give me some example of the different networks?
I have not worked it. I just have some theoretical understanding. I have not worked directly with those.
Okay, fine. Fine, no issues. Already. Coming to the NIC card. NIC card is the most important part of your computer for networking. If you want your system to join a network, it should definitely carry your NIC, because it's going to provide network services to the computer. See here, every computer must have NIC to communicate with other computers. So sometimes you will take add-on cards like this, and sometimes you will also see the on-board cards. So if you want to put a add-on card, where do you put it on the motherboard? Where do you fix your add-on NIC card on the motherboard?
I don't think it's required anymore. I mean, it's already built in, right?
Yeah, most of the times. This is the built-in one which you are seeing right now. This is the add-on one.
So this is just
if you need more than one, if you need more than one NIC, then built-in is just one, right?
Right. So this is in the
if you need to make your machine a multi-home computer, then
sorry, Samantha, you're breaking up. I couldn't hear you.
Okay, fine. Can you hear me now?
Yeah. Are you on a headset?
Yes. Yes.
Okay. That's fine. Okay.
Yeah, I was asking you, can you, where do you fix your NIC card on the motherboard?
Where do you fix?
Yeah. Did you ever try to open your computer?
No, I have not.
You must have done so many times. Didn't do?
No.
Not in your college days?
No.
All right. Try to do that once.
Okay.
So generally we put it in the PCI slot of the motherboard, right? Peripheral component interface. Now, so let's try to discuss about numbering systems. You might be wondering why we are trying to understand about numbering systems. CCNA is a complete number subject. You are going to use so many numbers here in the form of IP addresses, in the form of subnetting, supernetting, VLSMC. So many things are there. Every part carries numbers. Okay. So basically, before you try to understand IP addressing, we show you the conversion, how to convert the numbers from decimal to binary, binary to decimal, hexadecimal, and stuff like that, so that things will be easy for you to understand, right? So basically here we are going to discuss about 3 number systems: binary, decimal. Binary is base 2, it's going to use 2 digits, zeros and ones. Decimal is base 10, it is going to use the numbers from 0 to 9. And then we have hexadecimal, base 16. You're going to use the numbers from 0 to 9 and also alphabets A, B, C, D. A is going to take the place of 10, B takes the place of 11, and so on. So let's try a small conversion. Here I'm writing a decimal number 78, which I want to convert into binary and show. So whenever you are going to convert it into binary, you have to use the short division method. By using the short division method, you try to get the remainders. Whatever remainders you get, that becomes your answer here. Usually in division, your quotient is the answer, but here your remainders become your answer.
Okay.
Did you follow this?
Yes.
It's very simple. We are using the short division method. Binary means 2. So we try to divide it by number 2. Any number given, you have to divide it by number 2, and whatever remainders you get, that becomes your answer.
So what did you do? 39 divided by 2?
19. 2 ones are 2. 2 nines are 18. Remainder 1.
Okay, okay. So the remainder is on the side, okay.
Yeah, remainder is on the side. Yeah.
So what about the 9?
2 nines are 18. Remainder
Okay,
1.
okay. Okay, 2 4 0. Okay, so that, I understand. Okay.
Yeah.
Okay, and then 1 is just 0.
Yeah, you don't have any remainder, so you put 0.
Okay. All right.
Right. So next we will try to convert a given binary number into decimal. For this you are going to take the help of the 2 power table. We take the help of the 2 power table and we try to do this. See here, we try to convert, we try to raise the powers of 2, and then we try to multiply each number here with the above bit, and finally you get your answer, which is 107.
Okay, 2 4 6 8 10. Okay.
Right? So you can try this with various other numbers also. And here I am giving you a ready-made table to understand and to mug up. If you mug up this table, you can easily do your subnetting. While doing the subnetting, things will be easy for us. So here you are seeing the group of 8 bits. You will always see the group of 8 bits. You will understand why we are taking 8 bits each time, because in IP addressing, every octet contains 8 bits.
Okay.
Right?
So, yeah, so give me one. Okay, can you go back on this again? So I'm looking at this 1, 2, 4, 6, 8, 10, 12, 16. So why is it 128?
It's 128 because you keep on increasing from the right hand side. When you do it, it comes at 2 power 7 place. 2 power 7 gives you.
Right, but all of them is zeros.
Yes.
So 2,
Of
4,
course.
6, 8.
If all of them are ones, you get it as 255. See, you multiply them with zeros. When you multiply the answer with zeros, it becomes 0. And finally you have only 128.
Okay.
Right? See, observe the last one once.
Right.
Okay. So then you have one more table, the hexadecimal table. This will also help you. Right. And so let's talk about NIC card. Whenever we are talking about the NIC card, it's very important for us. Your NIC card consists of it comprises of 2 addresses. It usually carries 2 addresses with it. One is physical address and the other one is logical address. Where if you are talking about physical address refers to the MAC address of the NIC card, media access control address. It's a unique 12-digit hexadecimal address which cannot be reused. Right? So usually your MAC addresses, media access control addresses cannot be reused. And logical addresses, they can be reused. Logical addresses are nothing but your IP addresses. So usually as we are using IP address version 4, we will be using all version 4 addresses only. Version 6 is not yet into practice. See, these are the differences between your physical address and the MAC address and your logical address. Just go through once.
Okay.
If you try to put it in bits, it's a 48-bit address, and if you want to take it in digits, it's a 12-digit address.
Okay.
Right? Okay. Hexadecimal notation, we use hexadecimal notation to represent physical addresses, whereas IP addresses are written in dotted decimal notation. They are represented using dotted decimal notation.
Okay, so list 2 address, what is the list 2 and list 3 means?
That's layer 2 address, data link address, and layer 3 address, network layer address. OSI reference model from the OSI reference model.
So layer 3 is what you may call the router?
Yeah, router is a layer 3 device.
Okay, and
router
layer 2
works
is,
at layer.
right.
NIC card is a layer 1 device. NIC card works at physical layer.
Okay, and layer 2 device, what is a layer 2 device?
Your switch.
Okay, switch is a
switch and hubs.
Okay, all right.
Yeah.
Okay.
See here, you can see the MAC address, you can see the conversion here. Okay. Right?
Mm-hmm.
So So do you know how to assign an IP address to your machine? Did you try any time?
I have done it. It's been a while.
Okay, right. So see here. Generally, you go to the LAN card, you go to your NIC card. Once you install the NIC card and you install the drivers for that, after that you can see this NIC card icon here coming up under the network connections. Go to the properties. This is an old operating system, I suppose XP. But if you take up any Windows 7, Windows 8 operating systems, you have support for V4 and V6.
Okay.
Okay. See how to assign IP addresses. You can give the IP address statically or dynamically. So if your adapter says use the following IP address, it means we are using a static IP address, and if the adapter says obtain an IP address automatically, we are using a dynamic IP address. Right?
Okay.
So can you tell me which class IP address is this?
IP address automatically. This, I mean, I don't think any of these are static IP addresses, right?
Why not?
This is.
When I'm saying use the following IP address, it means I'm using a static IP address. Static IP address is something which is assigned manually.
Okay. Automatically means just the dynamic. Okay. Okay.
I think you're confused between public and private.
Right.
Okay. This is from class C. Right. Let's see how to check the IP address. Do you remember the command to check the IP address?
I'm trying to remember. Yeah, it was. Yeah, it's been a while.
Okay. So it is ipconfig for Windows operating system, and it is ifconfig for Linux operating system.
It's ipconfig, right?
Yeah, ipconfig. And you can also check the details about the MAC address by using /all.
Okay.
Now, how to get the MAC address of your machine? You also have a special command for MAC address, which is getMAC.
Okay.
Right? And how do you check the connectivity between two systems?
Is it a ping? You do ping?
Yes,
No.
exactly. You didn't forget ping. Why?
Huh? Simple to remember.
Yeah, good. So, what's the full form for ping?
What is what?
What is the full form for ping? It's an
I don't remember.
abbreviation actually. Yeah, it's Packet Internet Grouper.
Okay.
So you can ping with the name, or you can ping with the IP address of the machine. You can do self-pinging, you can do target pinging, you can do ping loopback address. Remember what is loopback address?
No.
Okay, loopback, generally we say ping 127.0.0.1. Whenever you want to check your NIC cards functionality, you want to check your NIC cards health, you will use ping loopback.
Okay.
Right?
Yes.
So that's a basic introduction for you.
Okay.
For today.
All
I mean, did you enroll? Did you enroll for the class?
Yes, I enrolled for the class.
Okay.
Okay, so let me
fine.
stop the recording. Yeah.
Yeah, you can stop.
Okay. Okay.
Right. Please let me know if you have any doubts in the topic or anything else. See, I will provide you with the material, the reading material. I will provide you with Cisco Packet Tracer for the practice. So we will be doing around 3 to 4 classes. We will be doing basics, and after that we will be moving on to the router basics. Then we will move on to the initial configuration of the router, static routing, dynamic routing. Then we go to the switching concepts. Then we do VLANs, VTP, STP, ACLs, wireless LAN. So many things are there.
Okay. So is there okay, so is there a curriculum that you provide that we go through or later on?
Yes, we do provide you. I mean, before I send you anything, I need to talk to these guys.
Right. So yeah, so I just recorded this. I'm not sure if it did record. I will need to check that.
I know it will be recorded, and you will see a file coming up now. You can play that in the media player or VLC media player or Windows media player.
Okay.
Yes, Mr. Irshad. Anything else?
No, that's
Any
it.
other
So I think
Clarifications you need?
so I'll go through your presentation that we just recorded, and what did you say? You said you were going to be providing some material after you talked to the team in California, right?
Yes.
Okay. And so the introductory first 3 or 4 classes will be the introductory classes that you're just going to cover the introduction.
Yeah, it's not going to be same thing which you saw today. We'll move
Okay.
on further with OSI layers and IP addressing version 4, cable
Okay.
systems, stuff
Okay.
like that.
Okay. All right. That's fine.
Okay. Any other details you want to know?
No. So how is the material going to be provided? That's fine. I mean, right now that's fine. I mean, so we'll just go one by one.
Yeah. We'll send you in the email.
Okay.
I think that's the usual way we do.
Okay.
Right. Any doubts so far? Did you follow everything? It was very basic kind of thing.
Yeah, it was a basic. It's just that there is for me to get back to the basics. I think it's just I just have to go and brush up on my part. Just kind of go
Yeah.
back. Yeah. So that I don't think that should be hard.
Right. Okay then. So can we meet tomorrow same time?
Say 9 o'clock, right?